Hello, welcome back. Some decisions have been made, and a couple of the gadgets that I described in the previous video have been made as well. This is the Delrin that's been turned down so that the smaller end is the mortise size of the stummel here, and the larger piece is a slip fit into this tube, and the tube has had its face ground to make cutting teeth. Also, the reason for only putting 3 teeth on there, if you're wondering about that, is not laziness. It's because it's the only way this kind of saw will work. It's in a confined space so that the chip it creates has nowhere to go. And if you have a bunch of fine teeth, which are much easier to grind, with every quarter turn, the wood fills the space between the teeth, and then from that point on it doesn't cut. So you want it like this, and you can get more out of it each time before you have to empty the chip. So that's how that works. The cracks have been filled with epoxy, and this is all obviously under compression. It's hardened now or cured. The materials used here, this is like a Ziploc bag type of plastic, because I smeared some epoxy on the outside of the shank. It's how you kind of scrub it in the cracks, like you're scraping mud off your boots or something, but you just keep doing that. It'll eventually get in there. And then wrap it in plastic, wrap that in leather so that these metal straps don't dent the wood, and squeeze it starting at the bottom and work your way up so that the thing comes together like a flower in reverse. And I'm happy to report that when I did that, there were some little micro beads of epoxy that emerged from the cracks as they compressed, so some got in there. Now what I'm about to dive into gets a little complicated in that there's a lot of digressive stuff that I will try not to go off onto, but without having a live audience to ask questions and stop me and stuff, all I do is just kind of dive in. So I'll do my best, and I wish you were here to ask questions, but it is what it is. So consider this a diagram of the side view, the profile of the shank of this same pipe with hose clamps on it. And the mortise is this guy here, of course, and the shank itself is all here. The bowl is off that direction over here. Now the proportions are a little wrong for the sake of illustration here. I've made the mortise both smaller in diameter and longer than it actually is, but that's to make the drawing a little more clear. These heavy black lines are about as far as I expect to get in using this saw. The deeper you go, the more surface area engages, both inside and outside. So after a while, it'll get heavier and heavier and heavier and tighter. And if you persist and like take a power tool or something to twist it, you actually risk breaking the shank of a pipe. Now this one not so much because it's enormous, but you got to be careful that you don't cross that line where it binds to the point you're literally going to snap the shank off by continuing to turn. But in the course of evaluating this when I was gluing it, I determined that the cracks are way deeper than I originally thought. In fact, they do go all the way up to the end of the mortise where it skinnies down with where the mortise gets thinner and goes into the airway. That's as far as these cracks go on the outside. So it's not going to be possible to use that tubular saw all the way down and then leave a chunk of metal in there. That's just not going to work. So the next option is almost ludicrously difficult, but this pipe is worth the effort. And here's what we're going to try to do. Since we cannot continue this, but we do have now, especially if we leave the bands on here, a way to support the tube itself in the end of the shank, like so. Remember, if this is going in there half an inch or something, we now have a guide for this, which is a large diameter drill bit that happens to be the same diameter on the outside as this is on the inside. Which means that we will then be able to cut with that drill bit in the following manner. This wood will become the victim, so to speak, of that giant drill bit. Remember, the tube is going to be in place. I'll even use silver graphite, the pencil here, to show you the tube, because the tube is now sticking out like so. We're slipping the drill bit down the tube, and it's the same diameter as the inside of the tube. So if we measure the depth of cut, we'll be able to drill in a coaxial fashion down to the end of the mortise here. And then once you retract the drill bit, you're left with a two-step hole. And it's bigger than it was, but it's still not what you want. So the next order of business is to remove the rest of this wood here on both sides. Well, it's not a side, it's a three-dimensional object, but you know what I'm saying. And the way to do that is with one of these. And because this has the spirals and the flutes and the reliefs and stuff, it will not load up as our little homemade tube saw will, but rather shave it away and channel the chip out so that we'll be able to crank this guy in. And by the way, this is in diameter. The outside diameter of this is the same as the outside diameter of this tube, which means that the guide for this is going to be the original sides of the hole here, the black guy. So in the same way that the tube became the guide for the drill bit, the sides right here, the sides of the first tubular cut we make, become the guide for this tool. And the sharp face on that is they're wider than the amount of wood left. So we will twist that all the way down. And when we're finished, we will have, in effect, done nothing more than greatly enlarge the diameter of the mortise. And we remained perfectly aligned in all three dimensions while doing so. Now the entire exercise, of course, would be trivial if there was a way to clamp the stummel in, in a 3D holder of some kind, like a milling machine that had something that could grab this without damaging it, and with computer optics could orient it in exactly the right position that a drill bit could then come in and enlarge that hole. It would be a simple thing for a CNC type machine, but you'd have to program it to do it one time. So this is probably less work than going through all of that. But that's all we're trying to do in a conceptual sense, is make the mortise larger in diameter. And this will do that. As complicated as it is, the difficulty is keeping everything aligned, because the last thing we want is to get a hole in there and have it crooked or the wrong diameter or any number of things, because we're dealing in thousandths of an inch for this to work. So once that is, the mortise is enlarged by this three-step method, we'll then cut a cylindrical piece of wood. And that one's not a good example. We'll take some briar from a block. Here we go, a briar block. Cut this into appropriate size, chuck it in a lathe, turn it down so that we have a perfect slip fit in outer diameter for that wooden piece, that we can slide it in the end there, and while it's on the lathe and we're turning down the outside, we'll drill a hole in it that's exactly the same size, or the right size, for this guy. So that's what we're going to do. And because doing this for a camera is very awkward, and I don't want to risk anything in this. This is some fussy business. So I've described what I'm going to do, and I'll get caught up with the videos at each step along the way, but I don't think you'll actually be watching me do it, because I have to put myself in such an awkward physical position. I can't see well and other things, and I'd hate for something to go sideways because I was trying to show it on camera. So there we go. I'll be back in a minute.